Hello, welcome to PTC AVIATION ACADEMY. This is Captain Lakshmi Mohan here, and today we're going to talk about what a stall is. So in the previous video, link on the description below, we have spoken about what are certain terminologies associated with stall. So before you get into this video, please take a look at that video so you can have the basic knowledge or the basic terminology associated with stalls. So in this video, we're going to talk about what is stall. So simply put, stall is loss of lift. It is a condition, that is an aerodynamic condition that happens to the aircraft when the wings of the aircraft cannot generate enough lift to carry its own weight. Okay, so while we get into, let's learn a little bit more about stall, that is coefficient of lift. Now coefficient of lift is an important term here, and it is nothing but for a given surface area of a wing. The coefficient of lift is nothing but equal to the pressure differential between the upper and lower surface of the wing divided by the dynamic pressure. Okay, so coefficient of lift also depends upon three things, that is the wing area, wing aspect ratio, and the shape of the aerofoil. So the shape of the aerofoil can be can directly affect what is the coefficient of lift for a given aerofoil, and for a given wing, the coefficient of lift is always going to be constant until and unless any other flaps or leading edge devices are used in order to extend its surface area. So it depends upon, again, area of the wing is something that you guys already know. Now something called as aspect ratio. Aspect ratio of the wing is nothing but the length of the wing, that is the entire wing span, divided by the chord line. Chord line is from the leading edge of the wing to the trailing edge of the wing. So that is called as aspect ratio. So for a given wing, the coefficient of lift is always going to be your pressure differential divided by your dynamic pressure. Okay. Now coefficient of lift max. When this coefficient of lift reaches the maximum value, that is the pressure differential between the upper and lower surface of the wings are maximum, and when the dynamic pressure is minimum, that's when you have the coefficient of lift, CL max. So when CL max is the maximum coefficient of lift the airfoil or the wing can produce, and beyond that, what happens is that the coefficient of lift or the lift force completely reduces. So this is called as coefficient of lift max. So if you take a look at this particular presentation here, if you see this particular, see the coefficient of lift is against the angle of attack here. And this is the wing, that aerofoil and the relative airflow that is there. So here you have laminar flow, then turbulent flow. This is for a let's say 0 degree angle of attack, you get a little bit of coefficient of lift. Now moving on to the next diagram, where you will see that here the coefficient of lift is slightly increased. The coefficient of lift is slightly increased here, and when you have 8 degrees angle of attack, and it starts having separation point, that is the airflow is no more attached to the wing, it is starting to separate. And when it is at around 12 degrees, which is where you have your maximum coefficient of lift, you will see that the separation point moves forward until it reaches the maximum, which is your CL max, which is right here. See, after that, if you further increase the angle of attack, the coefficient of lift is going to decrease. So now at this point, where you can see this is the critical angle of attack. So in previous video, you already understood what is angle of attack. Critical angle of attack is that angle of attack for a given aerofoil or a given section of wing, where you can produce the maximum coefficient of lift, and beyond, if any angle beyond that, the airplane will just simply stop producing any more lift. Okay, so this point over here is called CL max, which is maximum coefficient of lift, and the angle of attack associated, like for example, in this example you have 16 degrees is the angle of attack the airplane wing has to be on in order to have an aerodynamic condition called as stall. So now remember this, an aircraft can be stalled at any airspeed or at any altitude. Very important to remember this. You can't be like, okay, you can only stall at certain conditions. The airplane can stall at any given condition. You have to be mindful of when a stall happens, because stall can be pretty violent, and stall can also, especially when you're closer to the ground and you do not have enough time or altitude to recover, it can be catastrophic. So you'll have to remember that stall has to be prevented at any cost. And just like any other diagnosis, you have certain symptoms for stall which we'll get into. But before that, just take a look at this video and you will see what exactly happens when when a stall happens. Just take a look at this illustration so you will have an idea of what stall is. Alright, so now factors affecting stall. What are some of the factors that affect stall? So for example, the stall airspeed, the airspeed at which the stall happens, it depends upon the weight of the aircraft. Number one is the weight of the aircraft. So the more the weight of the aircraft, the more it needs, the wings need to generate lift. So what happens is that the airplane, a lighter airplane would stall at a lower airspeed, whereas a heavier airplane would stall at a higher airspeed. So it's directly proportional to the wing. As the weight of the aircraft increases, the stall speed of the aircraft also increases. Next is increasing with density altitude. Next video we'll be talking about what is a density altitude, but for now we just have to talk about what in a nutshell what a density altitude is. Density altitude is nothing but the altitude that the aircraft thinks it is flying. Okay, so it depends upon humidity, temperature and pressure of the atmosphere. We'll talk about it in detail. So if the density altitude is increased, the airplane's stalling speed will also increase. Okay, next is stall speed will decrease with increasing values of wing, which could be achieved by applying wing flaps or laser. That is, your stall speed will decrease. That is, if you have like I said before, if you have leading edge and trailing edge devices added to your wing, now the surface area of the wing is increased, and when the surface area of the wing is increased, more lift is generated, and when more lift is generated, it takes a longer time for the aircraft to stall. That means a lesser airspeed. Similarly, stall will decrease with increasing wing area. So if anything that increases the wing area or increases the camber of the wing or that changes the shape of the wing, that is going to decrease the stall speed. Lastly, stall speed will increase with increasing load factor. Now load factor is nothing but a ratio of the lift divided by weight. So anything like your G, 1G, 2G, you must have heard that, right? That is your load factor. So anytime your load factor is increased, that is anytime you're pulling a 2G or 3G, there your load factor is increased. So when your load factor increases, for example, if you are at a 60-degree turn or a steep turn, we call it in aviation. If you're in a 60-degree turn, the stall speed of the aircraft is significantly higher than when the aircraft is at straightened level. So when you're doing a steep turn, it is very, very, very important to make sure that you are at a speed higher than your maneuvering speed for the particular aircraft. So this is because the load factor of the aircraft is going to increase. If the load factor increases, the stall speed of the aircraft also increases. Okay, so these are some of the factors affecting stalls. Now coming to certain signs for incipient stall, so that you can remember, you can understand that these are some of the things that you have to note down before a stall happens. For example, incipient stall. Incipient stall is you're not completely stalling the aircraft, you're approaching stall in an incipient stall. So that is flight controls are less effective. So when you're flying and the flight controls become less effective, that's the first sign that stall is approaching. Speed is low and the speed is decreasing. This is one of the second symptom of the stall approaching. Third is nose attitude is higher than normal. So normal, then that is nose of the aircraft it pitches up and it will be higher than normal. Then light aerodynamic buffet. Light aerodynamic buffet means the turbulent airflow that is there over the wing close to the stall will go hit on your elevator, and also your yeah, exactly, your elevator. And now the elevator will start to move, so giving a light buffet on your control. So your control surface will be moving lightly like this. This is called as aerodynamic buffeting. And lastly, operation of stall warning or stall prevention device. So each aircraft will have a stall warning device or stall prevention device, which will alert the pilot that you're going to about to stall. In some more sophisticated aircraft, it will actually prevent stall. Okay, so these are some of the symptoms of an incipient stall. Similarly, you have some symptoms for a full stall. That is, the aircraft has already reached critical angle of attack and it's already stalled. So incipient stall is when you're about to stall, but full stall is when you're actually stalling the aircraft. So that is wing drop. So aircraft goes like this and suddenly at stall, the wing of the aircraft drops. That is, it's no more generating lift, so it will drop the entire aircraft along with the wing. Then the nose drop. So along with the wing drop, you'll also see that the nose of the aircraft is also coming down. Heavy aerodynamic buffet. So previously we said lighter, now it's going to get heavy aerodynamic buffet. And loss of height. You will obviously lose the height of the aircraft, you lose altitude from the aircraft. This is some of the signs of a fully developed stall. Lastly, recovery from the stall. Recovery from the stall should be immediately decrease the angle of attack from the critical angle of attack. Number 2, increase the power. If it is a power off stall, you increase the power of the aircraft, engine power. Then remove the flaps if flaps are there. You have to remove the flaps in stages. Keep your ailerons neutral, keep your rudders neutral. So these are some of the ways you can recover from a stall. So that's the end of this chapter on stalls. I hope you have understood what stall is, and I hope you never have to encounter a stall at a lower altitude. You can obviously practice during your flight training, but I hope none of you encounter a stall at a very low altitude, because that is going to be really quite catastrophic. So that's it for today. I hope you understood what is stall, and I hope you all have a wonderful day.